Alright, this is lesson 8.6a, elementary algebra, equations involving radicals. This is the last section of the chapter on radicals. And we have done lots of different things with square roots. We're going to continue on with that. But one of the things that we're going to do here is try to get rid of radicals in an equation. Now, up to this point, we have done things like simplify radicals, but we have not done anything with equations. So, for example, we did, like in 8.5, you were getting something like the cubed root of 12x cubed y to the fourth over 3. And you were asked to simplify that. Now, one of the differences, again, between simplify and solve is simplify happens when there's no equal sign. Solving happens when there is an equal sign. So that's what we're going to be doing today, is we're going to take everything you've learned about simplifying and we're going to start solving equations. One of the things that happens when you solve an equation is, if you can, you want to get rid of the radical sign. You cannot find out what x is if the radical sign is over x or a part of x. So you have to get rid of the radical sign in order to not only simplify, but solve for x. So how do we get rid of that stinking radical sign? All right, well, in the past, when you had an equation like this, how did you get rid of that 3? You did the opposite. You divided both sides by 3. If I had x plus 2 equals 8, how did you get rid of that 2? You did the opposite to both sides. And the same is true with radicals. We're going to do the opposite of the square root. And that is, we are going to square both sides. Okay? So when we square both sides, what happens? Let me get a red pen here. The squared and the radical and the index disappear. That's why you square both sides, is it makes the radical disappear. And you're left with 7 times 7 is 49. Now you don't have the radical, you just do the regular algebra that you're used to doing, and you get x equals 48 for your answer. Okay, so we solved for x, and we had to get rid of the radical sign. So let's check this. Let's plug 48 in for the original equation, and we get the square root of 49 equals 7. Is the square root of 49 7? Yes, it is, so therefore we're correct. Now, one of the things that's really, really, really important here, when you square both sides, like we did here to get rid of the radical sign, you have to check your problem. Because I think I mentioned this a few sections ago, there is this word, or words, extraneous roots. Extraneous roots happen sometimes, not all the time, sometimes when you square both sides of an equation. That means when you square both sides of an equation, an extraneous root is an extra root that doesn't work. And another name for root is answer. It's an answer that doesn't work. You did everything right, you did the algebra right, but you come up with an answer that when you check it, it doesn't work. And let me give you a little explanation here. All right, so let's take a false statement. 3 equals negative 3. That is wrong, because 3 and negative 3 are two completely different numbers. Okay? So what happens if I square both sides? I get 9 equals negative 3 times negative 3 is 9. Notice I get an equation of 9 equals 9 from two numbers that are not equal. So I can get 9 equals 9, which is true, but when I square 3 and I square negative 3, both of these answers work, but not necessarily is going to be a solution to my problem. So you have to check your answers, and we'll get into some of those that sometimes they work, sometimes they don't, and we'll do some so you can see how that all works. All right, let's go to example number 2. Square root of 2x minus 3 equals negative 9. All right, that blue is just not bright enough. Let's go with a yellow. All right, so what we're going to do here is we're going to square both sides. Okay? Automatically, what that means is 2x minus 3 loses its radical sign. Negative 9 times negative 9 is a positive 81. Okay? Now we're going to solve for x. So we add 3 to both sides. We're just going to do simple algebra now that we got rid of our radicals. 84 divided by 2, x equals 42. Yay. And normally you just go on. But in this section, remember, we have to check. So let's take our x equals 42 and put the 42 right here in for x and see what we get. 2 times 42 minus 3 equals negative 9. All right, let's solve that. 2 times 42 is 84 minus 3 equals negative 9. 84 minus 3 equals negative 9. What's the square root of 81? 9. Does that equal negative 9? No, it does not. That's an extraneous root right there. We did everything right, but when we solved it, we found out our solution doesn't check because it gives us a false statement right here. So therefore, the solution to this is the null set. There is no solution. Again, do not tell me that the answer is 0, because that's not the answer. The answer does not exist, so it cannot even be 0. So squaring both sides of the equation like we did up here gives me an extraneous solution right here. 42. 42 is an extraneous solution. It happens occasionally. We can always eliminate extraneous solutions by checking. So sometimes you might get two answers. And when you put one answer in here to check, it works, yay. Put another answer in here and check, and it doesn't work, so you throw that one out and you only get the one answer. Okay? And we'll get into some of those too. So let's jump to example number 3. And, of course, they keep throwing problems at us that get a little bit tougher every time. So we have that. All right, so one of the things that's different here than in the last one is in the last one we only had a radical on the left of the equal sign. In this one we have a radical and a number outside of the radical on this side. So what we have to do is we have to isolate the radical. What that means is we need to get the radical on one side of the equal sign by itself. So how do we get rid of a plus 3? Well, the same way we always have. We subtract it from both sides. And we're left with 3a minus 2 equals 2. That wasn't so hard. All right, next step, when we have a radical by itself on one side of the equal sign, we square both sides. The radical comes off. The 2 is squared. And we solve it just like normal. 3a then equals 6 divided by 3, a equals 2. All right, so now we have to put it in the original problem up there in yellow. So we have the square root of 3 times 2, our answer, minus 2, plus 3 equals 5. All right, so let's see if that's a true statement. Square root of 6 minus 2 plus 3 equals 5. 6 minus 2 is 4. And some of you can just do this, a lot of this in your head. Okay, so 5 equals 5. So it checks. Okay, so 2 is the solution set to this. So middle of page 575, it gives you how to solve equations. 4 steps. First step is isolate the radical, and that's what we did on this last one. Get the radical all by itself on one side of the equal sign, and we did that by subtracting 3 from both sides in example 3. Then you square both sides to get rid of the radical sign, and then you solve. And then step 4 is check. All right, so we're going to continue on with this. square root of x plus 15, and that equals x plus 3. Okay, and this is where a lot of students start making mistakes. So let's see if we can keep you from doing that. This isn't hard. It's just sometimes students aren't thinking through what they're supposed to do. Remember, step 2, square both sides of the equation. Okay? Now you get that. Square both sides, but that does not mean square the x and then square the 3. Okay? It does not mean that we put a 2 up here and a 2 up here. It means we square both sides of the equation. So put parentheses around the entire left side, the entire right side, and square it. Okay? So one of the things I need you to recognize first is step 1. Isolate the radical. It's already isolated. It's already on one side of the equal sign by itself, so we don't have to worry about that step. It's already done. Now we square both sides. Left side's easy. X plus 15. We just take the radical sign off. This side says x plus 3 times x plus 3. We do the FOIL method. X squared plus 3x plus 3x plus 9. Combine like terms. Okay, so I combine these. Alright, so I'm there. Now, we've got a quadratic equation here. We've got an x squared here. So that means we have to set this whole one side of the problem equal to 0. So we've got to move these over to this side so we get 0. So we're going to subtract 15 here, subtract 15 here. Minus 6. Okay. Now we're going to subtract x from both sides to get nothing over here. Okay. Now all I'm going to do here is I'm going to move this to the other side because I just like to have my problem that I'm solving on the left, and maybe it's because I'm left-handed, or that's just the way I've always done it or was taught that way, but if you're okay not doing it that way, that's fine. Okay, let's keep going here. Two numbers multiplied, and they give me negative 6 added together, give me a positive 5. Okay, let's see. Plus 6, negative 1. Okay, so x plus 6 equals 0. So x equals negative 6, x equals 1. Okay, so we get two answers here. So we have to try both of these answers and plug them into our original. Let me put the original up here. Okay, so let's start by putting x equals 6 in. So, square root of negative 6 plus 15 equals negative 6 plus 3. So we put negative 6 in for both of those. Negative 6 plus 15 is 9, and this is negative 3. Square root of 9 is 3, equals negative 3. Is not correct. So, this one does not work. Let's try 1. Square root of 1 plus 15, 16. 1 plus 3, square root of 16 is 4, equals 4. So that one works. So our answer of our answer of 1 does work because this is a true statement. We don't have to get the same thing here that we get over here. We just need to get a true statement, and that tells us that our problem works. Alright, so I'm going to stop here and continue on with 8.6 B as in boy for example 5.